Hello everyone, I am Amit Kumar and I am going to present Industrial Security System demo. This is the demo circuit for Industrial Security System. This is the initial phase of the system in which uh, the task is to turn off a motor. I have not used a motor here. I have used a LED instead to indicate that motor is running or not. The idea is to turn off the motor when the temperature rises above certain threshold limit. That temperature is set using this potentiometer, and temperature is sensed using this NTC thermistor, that is negative temperature coefficient thermistor. If the temperature rises, then the resistance of this device falls, and that is detected by the microcontroller. If the temperature rises above some certain threshold limit, then these LEDs indicate those things using a changing effect, and an alarm is also raised, and this green LED turns off, indicating that something wrong has happened, and this turns off. That means the motor will be turned off. We can connect here a motor. Let me show you. Now this is set to about 30 degrees Celsius, and we know that human body temperature is set to about 35 degrees Celsius. So that if we touch this sensor, then we can easily go beyond the threshold limit. Let us see. Yes, if we go beyond the limit, then an alarm is raised, and that is also shown by this chasing effect of LEDs. If we lift this thermistor, then again the conditions will be normal, as you can see after some time, because temperature falls down after a certain time. Yes, temperature has fallen in the sensor and conditions became normal, and this LED again turned on. We can again see. Yes, when temperature rises, then this LED turns off, and if conditions become normal, then again system works according to the set conditions. And there are also some buttons here. There are two buttons. One is for emergency, that is if we want to raise an alarm, then we can use this, and if we want to turn off the alarm but only want to show the changing LEDs, then we can use this button. As you can see, alarm sound stopped but LEDs are glowing. This is Node MCU, which I used for converting USB to serial, which is used for showing it on the PC. I have used UART in this to send data to the PC. As you can see in the serial monitor, temperature is currently 28.3 and the limit is set to about 30 degrees Celsius. Motor is in running condition and alarm is ready. If we touch the thermistor, then see, temperature is rising and it gone beyond the limit, and the motor stopped, and the buzzer is active. These all tasks are not performed simply. These are done using RTOS, that is real time operating system. I have made three tasks for doing that. That is a start alarm task, a start sensor task, and start telemetry task. A start alarm task has the highest priority, and a start sensor task has above normal priority, and a start telemetry task has below normal priority. This is done because if something wrong happens, then alarms should be triggered immediately. That will turn off the system, that is in our case motor or LED. So this should have highest priority. The sensor is given above normal priority such that it can call the ADC regularly to check the conditions. Telemetry task is given the lowest priority because if some data is not sent to the serial port, then there will be no any issue. It can be sent later. But if another tasks such as a start alarm task or start sensor task is delayed, then there can be some big issue which can cause some fire, and the system can be corrupted. So the priorities are set accordingly. We can see the codes. Firstly, let us see the start alarm task. In this task, we have uh, written the code for the changing effect of the LED and the buzzer, and this will also turn off the motor. Next, we have a start sensor task. In this, we are calling two ADCs. The ADC which is used for one ADC is used for the NTC thermistor, and the other ADC is used for the uh, potentiometer. These are called regularly to check the threshold limit and the temperature sensor value. In this way, this sensor task works. After that, we have a start telemetry task, which is used to send the motor status, the threshold status, the temperature status, and the alarm status. These three tasks run simultaneously using RTOS. We can see the configuration of the microcontroller. It is set to 84 megahertz. That is the maximum clock frequency of the STM32F401 and here we can see we have configured the ADC. We have selected the two channels, that is in 1 and in 2. Next we can see here the clock prescaler is 4, resolution is 12 bits. All the settings are done. And that is it for now. Thanks.